Okay, let's do another question on tree sketches and probability. And in this question we've got a bag containing 3 blue, 2 yellow and 7 green beads. So we've got 3 colours going on, which makes this slightly different. A bead is removed at random with replacement. With replacement, that makes this a relatively easy question because the bead is put back in the bag after you've pulled it out once. The second bead is removed. So 2 things are going on. Pull the bead out, make a note of the colour, put it back, shake the bag, pull out a second bead. Part A. Draw a tree sketch showing all colour combinations. Well, because we've got 1, 2, 3 coloured beads, there are going to be quite a few combinations of colours we can get out. So the tree sketch is going to be quite complicated for this. So part A, here we go. Let's see if you can see this. I don't want to make it too small, but I need plenty of space. The first go out of the bag. You can either get a blue, or you can get a yellow, or you can get a green. This is the first go. On each of them you need to write down what the probability of each branch occurring, and you need to write that as a fraction on the branch. So the chances of getting a blue bead, you don't just write the number 3 on, which I've noticed some of you do in some of the homeworks that you've been doing, because there's 3 blue beads. What you do is you say there are 3 blue beads out of how many beads in total? Well, 3 and 2 is 5, 5 and 7 is 12. So there are 3 chances out of 12, 3 blue beads out of 12. So the probability of getting a blue bead is 3/12. Likewise with yellow, there were 2 yellow beads out of 12. So there was a 2 out of 12 chance of getting a yellow bead. And for the green there were 7 green beads out of 12. So 7/12. 3/12 and 2/12 and 7/12 add up to 12/12, which is a certainty. It's a certainty that you either get a blue, a yellow or a green bead because there were no other beads you can get. 12/12 is a certainty on the probability scale. You must get one of them. Okay, now let's imagine that you take out a blue bead on the first go. Then you have a second go. What can you get? Well, you can get either another blue, a yellow or a green bead. So this is for the second go now. Okay, now alternatively, imagine that you got a yellow on the first go. What could you get on the second go? Now, when you've got lots of branches all cluttered up together, a tip that I could suggest to you is draw, say, the second set of 3 branches a little bit longer so they don't intermingle with the first set. So you could get a blue, a yellow or a green, like so. On the other hand, you could have got a green on the first go, and then on the second go, what can you get? You can have a blue, a yellow or a green, and I'll go back to shorter branches here so you don't get the cluttered effect. These are quite distinct and easy to see now. So you can see all these different branches. Now you've got to put the fractions on each of the branches, so take care. It's with replacement, so that the beads are put back in the bag after the first go. So every single time we started off with 12 beads in the bag to begin with, and for the second go we still have 12 beads in the bag. So these fractions will all still be out of 12. So there were 3 beads out of 12 on the first go for blues. On the second go, because it's put back, it'll still be 3 beads out of 12. And there will still be 2 out of 12 yellow, and still be 7 out of 12 for green. And this is going to give us the same fractions for every single branch every time we come across blue, yellow, green, because the fractions are not changing because it is a with replacement question. So yellow on the first go, but it's put back in. So for the second go, you still have a 3 out of 12 chance for blue, a 2 out of 12 chance for yellow, and a 7 out of 12 chance for green. First go you get a green, but it's put back in. Blue on the second go, 3 out of 12. Yellow on the second go, 2 out of 12. Green on the second go, 7 out of 12. So there you go, there's the tree sketch for that situation. Quite complicated because of the number of branches, but the fractions are very easy to work through because it's with replacement. It'd be a lot more difficult if it was without replacement because these fractions would all be changing all the time, and that would make it a much harder question. Okay, let's do part B over here. Part B says find the probability of getting 2 yellows. Let's just use the picture to help us. 2 yellows. So you're following this middle path here, which is that one. So it's yellow and yellow. That's how you need to rephrase the thing, using the word and, remember. So yellow is 2/12 for the first one. And, if you remember probability and, we replace with a time sign. And then you need a yellow for the second one. Well, that's the same fraction, 2/12, because it's a with replacement question. So you get 2/12 times 2/12. Okay, and that will work out to be 2 times 2 is 4, 12 times 12 is 144. That will cancel, share that by 4 goes once, share that by 4 it goes 36 times. And you get the answer 1/36. Obviously, do a side sum if you can't do 144 share by 4 in your head. So 144 share by 4, 4 into 1 doesn't go, so you say 4 into 14, we'll carry the 1 on, 4 into 14 goes 3 times, 3 4s are 12, carry 2 on, 4 into 24 goes exactly 6 times, so there you get the 36 that I showed you there. Okay, part C. Find the probability of not getting 2 greens. Well, if you're not going to get 2 greens, what could you get? Well, you could get a blue and a yellow, or a blue and a green, or a yellow and a blue, or a green and a yellow, or a green and a blue, or, well, I don't know, there's so many different combinations. It looks very difficult. It's actually not if you spot the quick way of doing it. Not getting 2 greens. Why don't you work out the probability of actually getting a green and another green, which is actually the chances of getting 2 greens first. Let's work that out first. Green and green. So green on the first go, 7/12, and times green on the second go, another 7/12. So that works out to be 49 out of 144, and that doesn't cancel. So that's the chances of getting green and green. And what we do now is just make use of the partner fraction to that. It's like, what's the chances of it raining? 90%. The chances of it not raining? 10%, because 90 and 10 make 100% certainty. Chances of it snowing 7/8. Chances of it not snowing 1/8, because 7/8 and 1/8 add together to give a whole 8/8. We do the same principle here. Chances of green and green, 49 over 144. So therefore, the probability of not getting 2 greens will be the partner fraction of 49 over 144, which I think, if you work it out, is 95 out of 144. And there you go. That's it. And that's the simplest way of getting to that answer. I would not even begin to think about saying not getting 2 greens is blue and yellow, yellow and blue, yellow and green, green. Take you a long time. You could actually get the right answer, but it would take you a long time, and the chances are you're going to make a silly mistake somewhere because there's so many different bits to it. Okay, that's the end of that question.